Why would you want to open it in the ArcGIS Pro? For more tools. ArcGIS Pro has 1,800 analytical tools. ArcGIS Online, this map viewer, has about 60, about 30 raster tools, 30 vector tools. So again, kind of touching on what I was talking about before with more data, more tools is not always better. If you can meet your goals with ArcGIS Online, use it. It is much more accessible, less tools to learn. ArcGIS Pro gives you more functionality, a little bit more of a learning curve. But the user interface looks pretty much the same, right? You get a map, you get some tools. ArcGIS Pro just has more tools. And it looks a lot more like Microsoft Office, really, than anything else. Contextual menus. And if you're in the Edit button, you just see the Edit tools. If you're in the View button, you just see the View tools. So it's very nice that way. But we're going to open it up in the Map Viewer. To me, I don't know, I kind of think about these things at nighttime when I'm on work travel. Why is it called the Map Viewer? That's kind of it's an inadequate name. It's not just a viewer. It's an online GIS is what it is. So we get some tools here. This is Map Viewer is the JavaScript 4.x viewer, whereas the classic was the 3.x. The 4.x is much superior. Instant gratification. We make some changes. We don't even have to say done. It's already, it changes it on the fly. So okay, I'm not even signed in, but there's some things I can do. For example, I can say, some of you know this, I can filter. I don't want to see all of those tornadoes. How many tornadoes do I have, by the way? On the left side, there's a show table, right, in the triple dots. There is a expanded set of tools there, and this show table is one of them. How many tornadoes do I have in the data set? How many tornado tracks are here? As evidenced in the table. $68,000. Wow. Okay, so you can see that from 1950, and if I do a reverse sort, 1950 to 2022, 72 years worth of tornadoes. It's from NOAA. Are there tornadoes in Saskatchewan and Manitoba? Okay, sure. And Kazakhstan, elsewhere in the world. Yes, indeed. But this data in this particular case is from the NOAA data set, so it's only USA. They don't stop at the Canadian border. They don't stop at the 49th parallel. But all that is to say is that understand your data, right? Know where it came from, what the spatial extent is, how it was collected, who created, how often it was updated. That is essential to our workshop today, and I'm just kind of giving that a light treatment right now, but it is really essential to this. But being the limited time that we have together, we wanted to explore some of these data sets. Okay, so in here, we've got, as you saw, lots of different attributes. Not tons, but what, about 40 different attributes in the table. This is the I part of GIS, right? For those of you who are just getting into GIS, this is the I part, the table of data. The G part is the map. It could be a 2D map, it could be a 3D map, it could be a satellite image, it could be land cover, land use, it could be vector data like tornadoes, points, lines, and polygons. So one of the things that we can do is on the right side, we can filter the data. So there's a little filter button. Ooh, I don't want to confine you folks to doing what I do, but try an expression in there. You could look at years, you could look at magnitude, right, the Fujita scale. You get this nice histogram here that you can drag around. Wow, I've got a lot of capabilities at my fingertips. And the nice thing about the JavaScript 4.x is that as I drag the histogram to populate my expression, wow, I'm seeing, and I'm getting a little bit of washed out here from the projector, but I'm seeing smaller and smaller number of tornadoes as I drag the magnitude out to the right side of the histogram. So now I'm only seeing the Oklahoma, the Alabama, the Michigan. Okay, so I only want to see, and I'm not just going to trust myself to drag this at the right spot. I'm going to actually say magnitude is at least 4, and I'm going to save that. Okay, now I truly only see according to the data set. We always have to say, according to the data set, this is what we can conclude, this is what we can infer, etc., right? It's all based on the data, which is, of course, the focus of our workshop. I really love GIS. Let me just, again, have a little moment, because sometimes it confirms our preconceived notion of how the world works, and sometimes it challenges our notion of how the world works, right? So if I just saw the Wizard of Oz movie year after year, I might think, oh, Kansas is always going to be #1 for tornadoes, which actually it isn't, because when you look at this, it is, what states kind of stand out for you?
Mississippi.
Yeah, South Central. Mississippi, Alabama, some Ohio, Kentucky, Oklahoma is also south of Oklahoma City. They had those big wide ones in 2011, 2012 that were like a kilometer wide. That's another attribute that we have on our tornado data set here. And then this big one right here, right? This is, unfortunately, some of you remember this one. Yeah, it went right through the middle of the city, so that was not a good day. That was a very sad day for sure. So all of these have attributes on them, correct? We can have multiple expressions, right? We could say magnitude is at least this and state is equal to New York, etc. Okay, so this isn't really a workshop on how to do things inside ArcGIS Online necessarily, but I wanted you to see a couple of things related to our data quality discussion, and that is as follows. If we zoom into one of these, maybe we'll go closer to home here for you all. We'll zoom into a couple of these. There's actually a couple that, well, there's this one in the southwest part of the state that met my criteria here back in 1985. No injuries and no fatalities, fortunately, but according to this, it was a Fujita of at least 4. Okay, well, gosh, we can zoom in really tight on these, but there's a couple of things I wanted to draw our attention to, and one of them is, if we change the base map on the left side, right, to satellite imagery or imagery hybrid, we can actually see some things in here. First of all, the predominant direction, right, is southwest to northeast, but some tornadoes follow a different trajectory. Another thing is we only have the touchdown and the liftoff points of these, but what's one thing that's really scary and unpredictable about tornadoes is that, do they follow a straight line in reality? Okay, so maybe to add an element of we don't know exactly where these go because we don't have the actual sinuous path that some of these follow, maybe we symbolize this in a sort of a wavy form. That's not really going to adequately tell people what the path of the tornado was either, but maybe it would imply some sort of a unpredictability, or maybe we make these fuzzy in terms of the symbology. There's lots of things we can do cartographically to convey the notion that we don't know, especially as we go back in time, that this tornado actually touched down or lifted off, in this case, at exactly location 79.43 north, or 79.43 west, 42 degrees, 0.05 north. Why is 79 negative? Good answer. Exactly. Right? We've got this whole thing going, right? We've laid the Cartesian coordinate system over the Earth's surface, and we've got an x-axis here, and we've got a y-axis, right? And we're over here, right? So we're negative on the x, we're positive on the y. We're north and we're west. Yep. So we're negative on one of those numbers there. Okay, but we have a lot of degrees of precision there, but we're not really fully confident. 1980s are sort of right in the middle there, but if this was the 1950s, 1960s, 1970s, we really wouldn't be that confident. Maybe we need to build some sort of a buffer around the touchdown and liftoff points, and we make that buffer larger to convey a sense of uncertainty for the older tornadoes. That's another thing we could do. Lastly, though, we have a lot of data at our fingertips, and we can filter, we can symbolize, we can create the pop-ups so that we're not getting every single thing that is in here. You know, this is all customizable, right? What goes in here is all customizable. So, but we've got that data from the Living Atlas of the World. Right now, it's still online, right? We haven't logged in even. So why would we log in here to this map? Why would we log into the ArcGIS Online system? What's one advantage of logging in, signing in? To download would be one advantage, yes. Because if we wanted to, yep.
Add these to your story maps and things like that. Or make that
Yes. To save it and use it in other applications, absolutely. Or even to, at a more basic level even, save this map so that I don't have to come back to this tomorrow and have to redo my magnitude, filter and zoom into this particular tornado that started in Pennsylvania, right, and went into New York. So all those reasons. That's why you would actually sign in. Okay? And there's others we could talk about. But absolutely. It's nice to know, though, that there's some ways that you can at least explore data without signing in. And as you're saying, if we sign in, we could also then export it and save it into ArcGIS Pro and then use it in other ways inside Pro that we can't do here in ArcGIS Online. We have certain amount of analytical tools here, but now with another reason to sign in is that when you sign into your MCC ArcGIS Online org, which I know is a kind of a mouthful, but the MCC ArcGIS Online organizational account that you folks have, if you signed in, you're going to see another button over here, which is really important to our discussion here, and that is the analysis button. If I wanted to compute the mean center, just as an example, of all of the tornadoes in New York, what's the mean center if I could balance a pencil point or a standard deviational ellipse, or if I wanted to find out how many tornadoes have occurred within X distance of Rochester. Those are the kinds of things I could do with an analysis tool, and I don't see the analysis tool unless I actually sign in. So that's another reason to actually sign in. But still, this example, Living Atlas of the World, you've got a data service here, and you can always go back to the properties, and up here under properties, you've got some information. I'm going to scroll down a little bit and look at the visible range is important. If you don't see your data, it's because you need to get this little black map scale, your current map extent, inside the blue bar. So sometimes layers have a visibility extent just because we don't want you to have to deal with lots of different ugly maps right at the beginning where you've got lots of data and you don't want to display it all at a certain scale. So, okay, that's interesting. Fascinating. Under information is important for our discussion here in this particular workshop, and that is this part right here. Where is the source coming from? In this case, we know we looked ever so briefly at the metadata before we brought it in, but you can always go back to it here. You don't have to go back out to the Living Atlas or some other place where you got the actual data layer. You can actually look at it in this source information. And if it's got some metadata, you can look at it inside your map viewer right here. Okay, so that to me is a excellent one-stop, first shop, and that is this number 3, start your search with the Living Atlas of the World. There is another guideline that, again, I'd love to hear your feedback on all this. ArcGIS Hub, I mentioned upstairs. It is a way for organizations to serve data. Local governments, nonprofits, some academic organizations, colleges, universities, etc., will serve data in this hub technology. In the number 4, and I'm back on the spatial reserves, modern strategies for finding geospatial data, is lots of examples. I'm going to open up the Boulder County ArcGIS Hub. Like many local, regional, national governments and other organizations, they've got a challenge where, okay, we've got a lot of data that we want to serve to the community. As you folks know, we are at the point where we've got no shortage of spatial data, but there are still lots of gaps around the world, right? There are still places where the data is copyrighted, it's held for national security reasons, it's not collected, there's a royalty fee on it, etc. Right? There's lots of reasons why there are still many gaps. But as time has gone on, more and more people, governments, organizations have said data is valuable and we want spatial data to be accessible to all. We're not going to charge royalties on it. We're not going to make it prohibitive for use. I was at the USGS, and the year after I left, they finally made the Landsat data free. This was a big moment. We used to be $800 a scene. And so naturally, as you probably would suspect, the data use on the Living Atlas of the World or I'm sorry, on the Landsat imagery, it went from like this to like this. So this was in 2008 when it became free instead of $800 a scene. The first time I taught over in England in 2000, I couldn't even get the national census data. Oh, Joseph, we can't give that out to you. It's royalty fee. You've got to pay royalty. I'm just an educator. Oh, but you've got to talk to the national stats people, etc. So over those decades that have followed, as you know, we've got a lot more data at our fingertips now with organizations realizing this is an asset that everybody needs to have and use. We're not going to restrict it. But there's still a long way to go. Yep. But one of the nice manifestations is that if an organization didn't have, like I was saying upstairs, the sort of infrastructure, the IT expertise to serve some sort of their own customized data portal, they can use ArcGIS Hub. You could use ArcGIS Hub. In fact, I would just encourage all the students to get familiar with this because organizations will ask you, can you create a hub site for us? Because we've got this treasure of stuff that we've now scanned or digitized, and now it's sitting around in files, and we want to serve it up because the Public Works, or the Parks and Rec, or the City Planning and Zoning, or whoever it is, wants to get it out there. So, okay, we have some open data information for this particular county. It doesn't have to be Boulder County, but it certainly is a place, a good example, I think, of some data. So if I go to any of these themes on the left side, you will see this kind of thing. Kind of looks familiar, right? It kind of looks like ArcGIS content, and it is. It's data services. So you can see what kind of data type it is on these hub sites. Feature layers or image tiles. There are various formats depending on what kind of format it is, dictates a little bit on what kind of tools you have to use at your fingertips. So in this case, I just went to floodplains, for example, and if I go into floodplains, you probably know what's coming next. It's going to give you a thumbnail and sometimes an actual interactive map inside ArcGIS Online. And so in this particular case, wow, I've got ArcGIS Online, and now I see, oh, interesting, I've got some floodplain data. Now, a lot of times, think about the audience for these hub sites. If I'm a general public person and I want to know if my property is in the floodplain or not, I'm just going to go here. They're not interested in digging deeper like you and I as data geeks do, right? We want to get that feature service and overlay land use or land cover or zoning or something like that on top of there. Obviously, this is an issue that affects many communities around the world. We had a big set of floods in 2013, just about 10 years and 2 months ago, that kind of blew a lot of these 500-year flood and 1,000-year flood plain models out of the water because it was like a lot of mountain front communities. You get a couple of hours of precipitation in a local area like this. It all comes down certain canyons, and we've got all these people living on the floodplains and in the Front Range of Colorado and many other places around the world, and that's not a good situation. So this is a key issue, and that's what I love about GIS. It's not just the data, right? I mean, these are issues that affect real people and everyday lives, and these are important issues that we have to grapple with. So, okay, I've got some choices here, and most hub sites will let you do the following. I can download the data. I can serve it up as, I can download it as I'm getting some cutoff here, but no worries, as a table of data, as a shapefile that I can bring into ArcGIS Pro, as an SHP. It's static though. Remember, if I lock it into a static format, is it going to be updated when the city and county, in this case, updates? No, I probably should go out and get the data service. So actually the preferred route is to consume the data service, feed the data service into your GIS. Because nowadays, as you know from being in this wonderful web-based world, we want the data to be updated. We don't want to have to manually update our own data every time there's an update of the. Think about your software updates. Ditto for ArcGIS Pro or ArcGIS Online or lots of other tools that you use nowadays. There is an automatic update, even on your phone, right? Your operating system on your phone. Hey, there's an update. Okay, ArcGIS Pro will tell you, hey, there's a new update available. So that's good, but it's also something to be aware of. Here,